Hi everyone, and welcome to this course. My name is Ron Zacharski, the instructor. This short video will cover the logistics for the course. In another video, I cover the topics of data mining and machine learning. The content of this course is located in 3 different locations. The logistics center of the course is this course GitHub repository. So if you're coming in from Canvas, just click on that link. If you want to go there directly, just go to github.com/Zacharski/ML class. And you may wonder, well, why are we using GitHub and not Canvas? Well, Git and GitHub are essential tools for software developers. So if your goal is to become a software developer, it's good to know these skills. And second, it's a good skill to have to list on your resume. So that's basically why we're using Git and GitHub. The first page of the GitHub repository, sorry for all those pop-ups, the first page of the GitHub repository is our syllabus. Make sure you read the syllabus in detail. I'm just going to cover a few highlights specifically related to logistics. I'll come back to this essentials in a second. So if we quickly scroll down to the Mastery Learning section of the syllabus, the logistics of this course are very different from other courses you've had, or probably very different from other courses you've had. And let me just bring up a slide here right quick. Other courses you've had are based on time-based learning, right? So here's a typical syllabus or schedule for an intro to programming course. And so let's get to this number, week 4, branching, flow control, and Boolean logic. So I guess that would be like if, then, else statements, among others. So we have 1 week dedicated to that. And if you seem to struggle, or if there's some people that have a little bit more problem and need a little bit more time, too bad, because the next week we'd immediately go to lists and tuples. So at the end of the course, you'll always be struggling, or it'll be difficult for you to understand if, then, else statements, right? We just are racing through this based on the average student. You know, you may have already had some programming and know if, then, else, and you'll just need a day or two to learn the Python specific ones if that's the language we're using in the intro class. So everyone has to go at the same speed. In contrast, if you took a private music lesson in college, you'd be going at your own pace, right? There's no week by week schedule. And it'd be silly to think that, if you don't master one particular thing, too bad, just go on to the next thing, right? So at the end of the semester, your grade will be based on the progress you made, the consistency of effort you made. So how well did you apply yourself to this course, your overall improvement. So everyone may start at a different location, but their improvement might be significant from where they started, and their technical development. So there's another part of the grade typically, which is jury, where you perform in front of the faculty of that particular instrument, but a lot of it is based on progress. So that's what we're going to do in this course, sort of. We're not going to have weeks of the course. I'll have in the syllabus, there's kind of a recommendation of if you want to get an A where you'd have to progress where you should be. But you're just going to proceed at your own pace. And if you need a little bit more time in something, you can take that time. So there are no hard deadlines for anything. You proceed at your own pace. So then how do we get a grade for the course? Well, there's going to be about 15 labs and 4 projects. That's a lot of coding you're going to be doing. But it depends on how much you complete. So if you've completed 12 labs and 3 projects, you'll get a B. If you complete a bit more, you'll get an A-. As this is just an example, a representative example. So how does grading actually work? Well, let's go back to the syllabus and find out. Okay, here's how you pass. So it says here that you get what's called experience points as you complete projects. So typically labs are all or nothing. If you make a mistake on a lab, I'll let you know and you go back and fix it so you can get the total grade, the number of points that you need. So if you make mistakes, you're not going to get half the points. You're just going to have to redo the lab until you get it correct, and I'll give you some guidance. And at the end of the semester, it depends on how many points you've accumulated, and that will be your grade. So that's how you pass. There's no, like you get a C on this assignment or a 75 on this assignment. You're gaining experience points. So the labs are about 30 points each, and it's an all or nothing thing. You can go back and fix it. There are these projects which are graded kind of depending on how well you do, but on average they're worth 150 points. So that's how you get points in the class, and that's how your grade is determined. Now let me scroll way back up. Sorry for this. You can see your progress in the course by looking at this experience point spreadsheet. If I can click on it, there we go. Right now it's completely empty because we haven't started the course, but let me go to one that we did last time. And here everyone's going to, let me just zoom up, sorry. Everyone has an avatar name because everyone can see this, and you can compare how you're doing compared to other people in the class. You don't know who those people are, but you'll get a rough idea how you're doing. You can see the XP that people are getting here, and I keep track. So the lab at Quick Start is 20 points, NumPy is 20, and then you get a bunch that are 30, some 35, but you don't see like fractions of points, right? And then they're accumulating these points, and they reach certain levels, and at the end of the semester they get different grades. So you can see how you're performing on this with this experience point spreadsheet. So everyone has access to this, you know from day to day how well you're doing. Okay, now let me talk briefly about labs and projects. So the main description of labs and projects is in this syllabus, and you can read that on your own, but let me just show you where those are. So here in the list that's in our repository, we have the labs and the projects. Let's do the labs first. Now, how labs work is you watch a video or a set of videos describing the lab or that bit of information. So here they are for decision trees. And you watch these videos, and this last one will show you an example of how it works in the programming language we're using, in the set of libraries we're using. So you get one example here. Let me get to the decision. Here's the decision tree notebook that you'll be working on. And you get a second description of decision trees in the notebook itself. There's some description of it. And here in other labs, you learned how to load data, divide it into features. So you've learned this, and we're just asking you to fill in these code cells. These are executable cells that you'll be working on. And then we get this example of decision trees and show you how to do it. And then later on, it says you try. Here's a different data set. So you're using the same steps you've seen above in the worksheet, and you're just applying them to this new data set. So those should be fairly straightforward. And if you need help, and with some you probably will, you just ask. You ask. I encourage people to ask for help. So labs are fairly step-by-step that I hopefully give you enough information that you can just follow along and do it. Projects, by contrast, and let me get to one. Let me do the Bach one here. I just give you some basic information about what the problem is, and you decide how to accomplish that task. There's no Jupyter notebook, no code to help you along. You're applying what you learned in the labs to a brand new problem, and you can figure out how to do it. So generally, I'll give you a data set. Here's the data set, this data file. I lay out what the problem is, and you decide how to do it, and you get some points based on how accurate you are in class. So projects are a bit more free form. So that's labs and projects. So what should you do the first week of class? I'm going back up to the beginning of the syllabus. What should you do the first week of class? It'll outline exactly how to get started with the course. So GitHub is one of the 3 resources for the class. The second is the set of videos we'll be using, and that's here, Inquiryum.com Machine-Learning. Let me get to that. Here's Inquiryum.com, and it has all the video lectures that you'll be using. They're pretty much walkthroughs of the Jupyter notebooks. The third resource is the way we communicate among each other, and that's our Slack channel. And why Slack, not Canvas? Same reason as GitHub. That Slack is pretty much used in all software development teams. Canvas, not so much. or not at all. So knowing Slack is a good thing to know as a software developer and a good thing to include on your resume. Canvas, no one really cares about. So let me show you a bit about that Slack. So this is a way of communicating among the group. So if you have a question, you can post it. If you know the answer and you can help someone, that'd be great as well. So you can communicate with me, or you can just ask a question to the general class. So that's Slack. Finally, let me mention what are the required materials for the class. You'll need, let me scroll down to it. Sorry, here we go. An account at Google Colab. It's free, or you can pay for an upgraded version, the Google Colab Pro. And there's a video describing what I think is the difference between Google Colab and Google Colab Pro and why it might be beneficial to go Pro. You'll need a laptop because you'll need access to all these resources. And instead of a textbook, we'll be using this Inquiryum's Machine Learning Fundamentals course. I know all of you have busy lives. You have family obligations, work obligations. You're trying to niche out a little bit of time just to have some enjoyment during the week. And this course is just a tiny fragment of what you're doing. And you have different motivations for taking this course. Maybe you have a passion for artificial intelligence and machine learning, so you're really focused on taking this course. Or maybe your passion is playing guitar and you're just trying to take this course to fulfill some requirement so you can get a day job to finance your passion, which is playing guitar. Or maybe you can't even figure out what your passion is. So everyone's different. And the best I could do is offer this course in a way that will kind of eliminate as much stress as possible, much anxiety, and try to make the course a little bit of fun. So that's my hope. A little bit of information on how you can accomplish that is right at the beginning of the syllabus and how to pass this course. Now, I've taught courses in computer science for, 15, 16 years. And here's what I've learned from teaching those courses, that what separates the A students from the C and F students isn't what they know. They could be brilliant, in other computer science courses or brilliant in math. What separates it is if they work to a schedule and if they stay focused during that time. So I've had people who are, performance majors in music that have done extremely well in classes. So it's not what you know, but can you create a schedule and keep that schedule right from the first week? Since we don't have a very specific week-by-week schedule that kind of forces you and encourages you and focuses, oh yeah, I have this due in this class. There is none of that. So you're going to have to create that schedule yourself. You're going to have to have some self-discipline. So that's it. Again, I don't want people to suffer. If you're suffering, get help on Slack, where I mentioned, where you can get information. Arrange a time to meet with me so we can work together so you can do well in the class and have some fun and, relax a little bit. So that's it. I hope you do well in the course. Take care. See you in the next video. Bye.